Hello, everybody, and welcome back to the second day of the first ever virtual NASA iTech Forum. If you missed day one, you missed a lot. There were a lot of incredible companies, a lot of really exciting conversations that were really fun to watch, and we're looking forward to another strong day of programming here. Today, we will be listening to Skyrora, NeuroFlow, orbitless drives, and Mojo Vision. The format for the day will be the same as yesterday. There will be a 15-minute video presentation from each company, followed by a live Q&A session. After that, the judges, who were introduced yesterday, will all be going into deep dive sessions in the afternoon. There will be a panel discussion that starts at 3 o'clock. And immediately following that panel discussion at 3:30, we will be announcing the winners of this year's iTech event. Before we get directly in, I'm sorry. Well, I do want to bring up that anyone who is excited about yesterday's content or is watching today and likes what they see, I would like to extend a welcome to be part of the NASA iTech team family. Please visit our website at nasaitech.org. If you're an investor, a company, a NASA stakeholder, anyone who likes what they see and would like to become part of the team, please contact us and let us know. Before we get into the presentations for the day, I'd like to introduce our guest speaker, Walt England. Walt England began serving as Deputy Associate Administrator for Programs in the Space Technology Mission Directorate at NASA headquarters just over a year ago, where he provides executive leadership and management oversight of 11 programs within STMD with an annual investment of over $1 billion. He is responsible for budget planning and technical execution and serves as the decisional authority for project and program content, ensuring that technology investments align with the NASA strategic plans and roadmaps. Welcome, Walt.
Hey, good morning, everybody. Thank you, Max, and thanks to the whole iTech team. First thing I want to do is congratulate all of the forum participants here. The fact that you're here today, it means that you came to us through a very competitive process and were selected by some of NASA's brightest minds and some external investors out there, so you obviously have something good that you're doing, and you're developing a technology that is certainly of interest to NASA and obviously to the outside world. So I wanted to congratulate all of you. I'm really looking forward to today's activities. I wanted to say thank you first to Kira Blackwell, who has basically created this program over the last 3.5 years. And we're really excited that Max is coming on board. Kira is moving on to bigger and better things, and Max Briggs is coming on board to take over the leadership. So we're looking forward to seeing where the program goes with Max, and wanted to send off Kira with our thanks. So what I'd like to do is spend a few minutes, just tell you a little bit about the Space Technology Organization. We have a portfolio, as Max said, of 11 programs that span the technology readiness level spectrum from what we call the early stage all the way up through technology demonstrations. It's about $1 billion, $1.1 billion actually, in the FY20 budget worth of technology investment. So we're doing things from very nascent, early stage laboratory technologies all the way up through demonstrating things in space and ready for infusion into a NASA mission or other aerospace mission capability. So we've got 5 portfolios. You can see them here on this chart. Starting at the left, the early stage innovation portfolio includes things like the NASA Innovative Advanced Concepts, or NIAC program. Space Tech Research Grants is really our program that works with the university and academic communities, both at the student level and at the faculty level. We've got a Center Innovation Fund where we pair up early career NASA employees with essentially early career industry people to get some hands-on development earlier in their career. Moving up the technology readiness level spectrum, partnerships and technology transfer. We run the agency's tech transfer program. So taking NASA-developed technologies and spinning those out to industry and commercial. And then iTech program, which is all what we're here for today, is essentially the spin-in opportunity. So taking technologies that are being developed by companies like yours and developing them for NASA use. Prizes and challenges is really a creative crowdsourcing activity that we've stood up the last few years, working with commercial companies and entities outside in a prize competition competitive sense. So we're really excited about those three programs, and I think those are probably areas that would be of interest to all of you as well, if you're looking to expand your opportunities with NASA beyond iTech. Moving to the right up the spectrum, the Small Business Innovative Research Program, we run that again for the agency, so that spans all of the agency's mission directorate programs. That's another great opportunity for small companies to partner with NASA and develop innovative new technologies. The solicitation for that, we just yesterday, in fact, selected the new topic areas. So in about December, you should see a call for the SBIR program for the FY21 solicitation. That's an over $200 million, probably approaching $250 million opportunity this year. So I would suggest you pay attention to that if you're interested in expanding the reach with NASA. Moving up the scale there, technology maturation, we've got the game-changing development program, which takes technologies over what we call the valley of death, the TRL valley of death, from essentially technology readiness level of 3 in a laboratory, develops them in a prototype sense, and it strives to demonstrate them in a relevant environment. So maybe not all the way to a space flight demonstration, but basically through a ground development program and ground demonstrations that would ready them for a real space flight demonstration. We've got the Lunar Surface Innovation Initiative, which isn't really a program, but is an attempt that we just stood up this year to focus a lot of our efforts on NASA's mission to the moon. So to basically develop technologies across the TRL spectrum and focus them on lunar surface for a sustained presence. But I'll talk about that more here in just a few minutes. And then finally, at the far right end of the spectrum there, the technology demonstration programs, which includes technology demonstration missions, small spacecraft technologies, and flight opportunities. That really is the set of programs we use to demonstrate and infuse technologies, ready them for infusion. The TDM program is essentially an opportunity to demonstrate large-scale space flight hardware development in a space environment. Typically, we partner with other mission directorates. Sometimes we actually buy launches specific for an STMD-developed technology. But the goal there is to develop the technologies to the point where they are ready for handoff to a NASA or other commercial spaceflight mission. Small spacecraft technologies is just what it sounds like. We're developing technologies specific to the emerging CubeSat and small spacecraft community, which is just burgeoning. Probably the likes of things like SpaceX and others are doing, Planet Labs. It's just the amazing, the explosion of small spacecraft and the capabilities that they are bringing at a significantly reduced cost. So STMD is investing significantly in technologies that will continue to enable those capabilities. And then finally, Flight Opportunities is a program where we actually offer rides, either suborbital or sometimes high-altitude balloons, and even orbital launch opportunities to fly technologies that are ready for demonstration. Okay, now we go to the next slide, please. I thought I'd take a few minutes and just give you a quick overview of the Artemis program, our plans to send the next man and the first American woman to the moon, and then develop the infrastructure for sustained presence on the moon. We are on the cusp of demonstrating NASA's new launch capability, the SLS and Orion spacecraft, probably about this time next year in the fall of 2021, assuming everything goes well with the green run tests that are starting up this month. We're also developing the first pieces of the lunar gateway, the power propulsion element, which will essentially be an orbital outpost in cislunar space for lunar exploration and even for deep space, Mars and beyond. Down at the bottom there, you can see we're starting up what we call a robotic lunar precursor program, something called CLIPS program, Commercial Lunar Payload Services, which is essentially modeled after commercial crew and commercial cargo launch services, where we're buying services from industry to deliver our payloads and industry payloads for demonstration on the lunar surface in advance of a human presence. So we're actually starting with a couple of missions next year. FY21, early 22, we've got some space technology mission directorate developed payloads for that. And in FY23, we're actually going to develop the Viper rover, and which will demonstrate a number of instruments on a small lunar rover. So we're excited about that. If we go to the next page, all of that is really setting us up for what we call the sustained presence on the moon. Go back one. We're not doing the flags and footprints thing again. NASA's plans are to develop an infrastructure and develop technologies that will allow us to basically learn how to live and operate on the lunar surface in a sustained capacity. Beyond the Artemis 1, 2, and 3 missions, we're developing a number of capabilities. The lunar terrain vehicle, which would essentially be a 21st century moon buggy, surface habitat, so astronauts can live and work on the surface of the moon for up to 30 days. Actually, a pressurized rover, which will be a self-contained, compact, pressurized mobile capability for lunar exploration. And STMD is investing in surface power, both solar power, fuel cells, and even nuclear fission power for long-term sustained power capabilities on the surface. So all of that is really with an eye towards Mars exploration, human Mars exploration. In fact, if we go to the next slide, many of the things that we are doing and demonstrating on the lunar surface, we're doing with an eye towards going to Mars with humans in the late 2030s. There are a number of things that we can actually do and demonstrate on the lunar surface and have direct traceability and will enable us to do surface exploration on Mars with astronauts. You can see, if you look closely, I don't know how well it shows up on your screen here, but there's a trace from about 6 or 7 of these lunar capabilities that we intend to demonstrate that basically feed directly into Mars exploration. Things like the advanced power systems, in situ resource utilization, which we essentially use resources on the lunar surface and regolith, like extracting the water ice and turning those into oxygen and propellant. Advanced life support systems that we can demonstrate on the moon for human health and safety, advanced materials and structures, and autonomous systems. All of these things that we're doing for a long-term sustained presence may need to run autonomously, either with or without astronauts in person. And we think that's a critical element for deep space exploration as well. One other thing I'll say about Mars exploration, there are a whole host of things, many of which we just discussed, that we can demonstrate on the lunar surface or in cislunar space that feed forward to Mars. There are a number of things we just can't. We actually have to demonstrate at Mars. And a couple of those are things like the heavy payloads. We just launched this summer the Perseverance rover that's on its way to Mars as we speak, very similar to the Mars Science Laboratory Curiosity rover that we sent in 2012. It's about 1 metric ton, a little over 2,000 Earth pounds. That's the largest thing we have ever landed on the surface of Mars. If you want to send humans to Mars, land humans on the surface of Mars and enable the capability for them to get back off the surface and return to Earth, we need to land up to about 20 metric tons of infrastructure and capability. So there's a huge leap from that 1 metric ton to 20 metric tons. And given the fact that Mars has a pretty substantial atmosphere, we cannot demonstrate that in a lunar capability. So Things like advanced propulsion, we're developing nuclear propulsion technologies, nuclear thermal and potentially nuclear electric propulsion that will enable us to get to Mars faster and return. So those are additional investments that STMD and NASA is making to essentially enable long-term Mars exploration. So I just want to tell you we're really excited about that and hope that some of the technologies you are bringing to the table will enable or even enhance our capacity to do that. So we're looking forward to today hearing what you're bringing to the table, and I wish you all the best of luck. I'm really excited about this, and I will plan to join in later this afternoon to see who's going to take the grand prize. So thanks again, and best of luck to everybody. Back to you, Max. Max, I think you are muted.
Thank you. Sorry about that. So Walt, if you do you have time for a quick question?
I could probably take a quick question or two, Max. I don't want to dig into your entrepreneur's time, but fire away.
Yeah, no, we have just a minute before the first group is scheduled to go. So I did want to just ask you how STMD or NASA at large views kind of the commercial the commercial sector as a mechanism for enhancing the capabilities of NASA or STMD. It seems that that relationship is evolving, and from SpaceX and different ways to procure launches to just the way we engage private industry in general. And I'm wondering, I wanted to hear if you'd have any ideas on how that fits within the construct of STMD's programs and their pipeline and their kind of tech maturation strategy.
Yeah, sure. That's a great question. First of all, let me just say, commercial industry is an essential element, and we view them as essential partners in the whole space exploration arena. I mean, the things that companies like SpaceX and Blue Origin and others have done in the last 5 or 10 years to develop a capability to launch payloads and even astronauts in the low Earth orbit is just tremendous for us, because what that does is frees up resources for NASA then to invest in and develop capabilities and technologies to do exploration beyond low Earth orbit. Within Space Technology Mission Directorate, we're $1 billion plus $1.1 billion enterprise, and we invest about 50% of that directly with commercial companies. About half of that is in-house development, NASA in-house development. About half is our contracts with private industry. So they are essential to our long-term investment strategy and development for exploration and technologies.
Thank you, Walt. That's great, and I think the audience here is excited to hear that and hear about how they fit into that mix. I appreciate your time, Walt. Thank you for coming and speaking, and I hope you have a good time seeing whatever parts of the presentations that you can see over the next couple days, or well, I'm sorry, next couple hours. But
okay, hey, thanks again. Best of luck to everybody. We'll see you.
Now we are a little bit early here, but I think that we are going to get going and start the video programming. We will start with Skyrora Technologies. Excited to hear what you guys have to offer. Thank you.
Good afternoon, my name's Derek Harris and I'm here to talk to you about Ecoscene by Skyrora. You're just about to watch my video presentation, which I hope you all enjoy, and I'm happy to answer any questions at the end. Thank you. Humankind is always stretched for the next technological milestone, and sometimes this can bring around life-changing advancements. We've moved from the steam engine through to mass production and currently the digital revolution. The mass production revolution has brought to us techniques to make items for consumers at a quicker rate. Though this has not always been a good thing, especially when it comes to plastics. Items that would normally be made of other materials have now been replaced by plastics, a cheaper solution to meet the needs of the consumer. Though with the abundance of ready-made material, we have created a much larger problem. Single-use plastics and landfill waste. You can see all around the world the waste produced by humankind in mass dump sites, and worst of all, our oceans. There are now more patches developing, like the Pacific Garbage Patch, which is twice the size of Texas than ever before. So how does this affect you and me and the people around the world? Well, we're poisoning our own environment and even our own food chain. As you can see, the marine life see floating plastics as potential food source, and it is now beginning to end up in our food chain. Here at Skyrora, we're always looking for new ways to make a greener and more ecologically friendly launch program. Skyrora held a competition to allow people to enter new ideas, aimed towards the core value of an environmental focus. The prize was a grant which was funded by the Skyrora CEO, Vladimir Levikin. Along with the funding was the opportunity to work with Skyrora's technical team to refine the idea with the aim of bringing the product and company to market. Thanks to this competition, Ecoscene was born. Ecoscene is a synthetic alternative fuel which is made from previously single-use plastic products. It could be polystyrene that protected your new television, or the wrap that goes around farmers' hay bales to keep them fresh for the winter months. Given a chance for these plastics to be given a second chance, rather than being banished to a landfill or to be incinerated. For every 1,000 kilograms of waste plastics processed, we are able to produce up to 600 kilograms of usable fuels. So let's take a look at the science of our process. Today, safe and complete recycling of many different types of waste quite rightly attracts a lot of attention from all over the world. That's why a new approach to waste proclamation is needed. Skyrora, the UK's leading launch vehicle company, has developed the equipment and technology to convert the waste hydrocarbon materials such as non-recyclable plastics, rubber, waste oils and sludge into a liquid fuel. The system is based on the well-known method of pyrolysis, with some of our own technological hardware improvements. The main advantage of our technology is the use of a natural catalyst which is readily available around the world. By using the catalyst, this helps to decrease the processing time and increase the output of the final product and allows for lower temperatures throughout the entire process. The product, which are processed in a mixture with the catalyst paste, are loaded into a detachable retort, which are mounted inside the furnaces. The simple interchangeable design of the retorts allow for them to be swapped out quickly and without any extra cost. The retort inside the furnace is heated up by the gases that are involved in the process of pyrolysis. The equipment also has a separate unit for collecting, compressing, storing and dispensing the produced gas through a burner. To simplify the production of the lightest fuels and commodity fractions in the manufacturing process, the setup has a fractionation chamber where liquid fractions are extracted. The resulting product is separated into two streams. The first stream is a heavy fraction which goes for recycling or as a heavy fuel oil. The second stream is a mixture of water, petroleum, diesel and gas. The second stream is fed into the arresters, which then separates gravitationally into the water, liquid hydrocarbon and gases. The production process is controlled from a single operational panel, where the temperature, pressure and other information at the control point is displayed, as well as the liquid level of each of the tanks. Some parameters can also be managed remotely. Coke ash from operation is easily removed from the retort once it is cooled, a process which can easily be mechanised. Natural resources are exhaustible, and more secondary are produced than can currently be reprocessed. The advantage of our system is that the synthetic fuels do not need to be extracted from primary exhaustible resources, such as minerals, oil and gas, but from secondary resources, even ones that cannot normally be recycled. Thanks to this tech, 100% of the input product is utilised, which increases commodity output. Its small size, modular design and simplicity of use allows it to be installed on waste collection sites, burial sites or even on a boat. The next step for Ecoscene is to certify our fuels and make any adaptations required for the aerospace and aviation industry, to help the industry as a whole become more environmentally friendly. The key to this project is the ability of Ecoscene to be refined and blended to be able to produce RP1 kerosene as well as Jet A1 fuel. As part of our market analysis, we took the most popular planes in the market being used by the aviation industry and found out that the average long-haul flight used 8.7 kilograms per kilometre of Jet A1 fuel. So imagine a single plane travelling from London to New York, which is a distance of 5,555 kilometres, is covered by burning over 48,000 kilograms of fuel. As of June 2020, the Defence Logistics Agency confirmed the price per gallon of Jet A1 fuel at $2.36. For Ecoscene to be economical and ecological, we would need to market the fuel around the $2.36 range. Skyrora has open conversations with the local authorities in Scotland over the waste plastic costs and current contracts. One of the local authorities, who are in early levels of discussion, is Fife Council, and they have confirmed their present method of plastic disposal is to filter out PET products and send the rest to landfill or incineration. This process has a sliding cost scale, depending on the types of plastics being disposed. For example, for 1 tonne of polystyrene waste, it would cost $114 per tonne. Alternatively, PVC would cost $160 per tonne to dispose of. This has allowed us to start negotiations for feedstock with local councils and companies, allowing for us to be paid to take the waste as well as process this into a product. The financial model will provide us a positive cash flow throughout the entire process. Our expectation is to agree a fee between $20 and $50 per mixed tonne of plastics. This fee will cover our costs of sorting to remove PVC from the delivered waste, as this plastic cannot be used in the process. Our analysis for production of Ecoscene, upon scale up from the demonstrator to a full-size plant, we estimate the cost of production of RP1 or Jet A1 fuels at around $1.50 per kilogram, leaving us in a competitive marketplace for selling a greener alternative fuel. To assist with the comparisons, we've used the assumption of weight for Jet A1 being 0.81 kilos to the equivalent of the US gallon. Ecosene have already agreed an anchor client with Skyrora. Skyrora have used their rocket engines to qualify the RP1 and Jet A1 quality. Skyrora aim to launch 16 vehicles a year, as well as testing over 160 engines a year. As part of Ecosene's development under the Skyrora branding, a deal has been confirmed to supply Ecosene for these launches and tasks. We have entered into early discussions over licensing agreements with a progressive European country who's interested in the technology to help power all its internal flights. The fee for is currently in discussion, but when signed would provide a guaranteed income to the company to allow for future expansions. The plans to bring Ecosene to market has been delayed by the global pandemic, but has not stopped the team pushing forward. We're currently in a grant process to cover the cost of the first full plant in Scotland with Zero Waste Scotland. Zero Waste Scotland is a national initiative to have no waste going to landfill by 2030. We have been entering Ecosene into relevant awards and competitions to help prove out our business plan and pitch. As of September 2020, Skyrora and Ecosene have been awarded the following: the Leif Erikson Lunar Award, Clean Tech Go Tech Awards, the Environmental Best Practice at the Green Apple Award, the Net Zero Energy Innovation Pitch Award, and Scotland Business Awards for the Innovation Award. Our environment is no longer just a character to be used in a Hollywood film. Around the world, thanks to the innovation of the digital age, we are more aware of the damage we cause to the Earth than ever before. The United Nations Sustainability Goals were established to provide a better future for the entire Earth. From affordable, cleaner energy to sustainable community. 17 goals to protect our environment. It would be easy to say we owe this to our children, to solve the messes that we've made, but it's still not enough. For real change, we need to roll up our sleeves and prepare to get dirty. I've brought Ecosene here today for two reasons. The first, to highlight that plastics can play a part in a larger circular economy for the aviation and launch industry. Secondly, the United Nations Sustainable Development Goal number 17, Partnerships for the Goals. But I came here today to look for partners in line with the UN Sustainable Development Goals. It could be a company looking for a high quality fuel, or a sustainable investment fund manager looking for ways to invest, or even an airport who wants to follow those around the world that are now beginning to change their ways. I know Ecosene can disrupt different sectors, from alternative fuel markets for aviation to space and beyond. The only limits are the ones that we will place in front of ourselves. NASA has always looked to lead the way with some of the biggest and brightest ideas in trailblazing ways. It is no surprise that by hosting NASA's iTech Awards, it gives all the companies you have seen here today or will see the platform to make the correct partnerships. I thank you for your time today and would like to leave by asking you a question. What can you do today to make a change for tomorrow? My answer is Ecosene. What will yours be?
Thank you so much. Ramona, let's open up the questions.
Yes, I understand that your first plant will be located in Scotland. How do you plan to approach other plants? Will you keep them under your company control, or will you franchise out, or what is that? I didn't quite catch all of that.
Hi there. Thank you, Ramona. Well, first of all, our intentions are we will look to have the plant with herself for the first one, but after that, we're looking at sort of license agreements, as it said in the video, with potential Northern European country. We're looking to license that technology to them to be able to use it.
What about for the rest of the world?
Yep, certainly the rest of the world is on there, and through some contacts I've met on NASA iTech and some other discussions, we have got a few discussions ongoing for some areas in America as well as Asia.
Thank you.
All right, John, you had a question?
Yeah, Derek, hey, thanks for the presentation. Great technology. Can you talk more about the space application through Skyrora, specifically to what orbits are they aiming and how much mass, and then anything else you'd like to add to that?
Yeah, certainly. So Skyrora are aiming to go to the polar orbits and sun synchronous orbits, and they can take up to 315, that's 315 kilograms per launch. The good thing about it is our top stage can start and stop in the vacuum, which allows us to deliver small sats and CubeSats to their designated areas before sending it back to burn up on re-entry.
Thank you.
Can you describe your IP portfolio? What do you have to protect this technologies?
Yeah, certainly with that, at this present moment in time, part of the system is general to market use, which has been seen by and can be used, so the pyrolysis side of things. There are a small portfolio which are currently with our legal team being reviewed before being put forward for patents on this, and we expect that to happen in the sort of next 6 months.
With the mix of plastics that you use as the raw materials, how do you control the contaminants in there? I mean, do you have trouble with that, or is it straightforward in your pyrolysis approach?
With that, there is a little bit of a technique to that, which is something that I can answer off screen rather than on screen for this one.
Okay, but you have ways of removing things like sulfur and stuff like that?
Yes, there's ways to make it more sort of pure.
Thank you.
Hey, Derek, Jim Young. Interesting presentation. Appreciate it. Just a quick question. Can you share any insight on just the financial picture of the company currently?
Yeah, certainly with that. So at present moment in time, it is funded alongside Skyrora with that. So what we're looking at is raising funding through the Zero Waste Scotland, which will be somewhere between 200 and 600,000, which will allow for the very first batch or plant to be opened in Scotland. At this point, we believe that we can make it smaller if it's required to, or make it larger, and depending on which sort of way we go. So if we go for smaller to make it compact for boats, for example, going out to the Pacific trash patches, it'll be a much smaller amount of capex needed for that. Whereas if we want to make it go bigger, which I think we will do on some central parts, so for example, with the spaceports coming to Scotland, we'll want a larger one near there. It would require just a little bit more, so double that maybe. But we are looking to find ways that we can reduce that down as well in cost purposes.
Thank you.
Derek, this is Dallas Bainhoff. How are you?
I'm good, Dallas, and yourself?
Great. Have you thought about becoming an engine manufacturer for larger engines so you can sell engines to other rocket companies along with your fuel to expand your business that way? Yeah,
certainly. Skyrora has got a lot of things that have spun out of its R&D process between 3D printing, EcoScene, which brought us here today, and basically engines is another one, 3D printing the engines. So it is something that is on the cards and currently being looked at.
Can you say something about the production capacity of your Scotland plant, what you predict that it's going to be? And is that enough that you can run, that you would supply the fuel for a whole airport?
Yeah, certainly with that, it would depend upon the airports in Scotland. And at the moment, trying to get a full figure from the airports has obviously changed due to the pandemic. But what we anticipate, we would need maybe about 3 times the size of the demonstrator we have to run one airport for up to a month in that regard. So we're looking at Edinburgh Airport when we're discussing that. But the fuel intake, it would need to be running 24/7 and be 3 times the size of the demonstrator.
Hey, Derek, this is Ben Lockman. What's your power requirement for input power to the system? Is it do you use external power, or is it powered through feedstock?
With that, there's very minimal power coming from external with that. So the feedstock does provide the way for heating the pyrolysis and such. So most of it is taking off the actual feedstock going in. So for every 1,000 kilograms of waste that goes in, about 600 kilograms of fuel comes out. So 400 is used for sort of powering the whole process along.
All right, Sherman, you have a question?
Yes. How are you doing? My name is Sherman Williams. My question is, what is the environmental impact caused by your recycling process? Just want to make sure the juice is worth the squeeze.
No, that's a very good question. So certainly with that, when the processes go through, none of the gases are released. So normally if you were to bury the plastics or burn them, most of it will be sequestered into the ground, so it won't escape that way. With our process, because we use all the gases in the process, it means that they're not being released out into the environment. At the end of it, the actual fuel that comes out of it has a lower content of sulfur and other sort of contaminants, you could say, than the normal kerosene or jet A1 would have.
Got it. And then how much money has your company raised thus far?
Sorry, Sherman, you broke up there.
How much money has your company raised thus far?
So far with this, the money spent on this are invested into it is in the range of about 750,000 pounds. So, and I think in US dollars, that's about 900,000.
All right. Any other questions?
Derek, this is Kurt Sackstetter. I think excellent presentation, very interesting. I think that, one concern that you would eventually have would be ways to scale up your production to, larger and larger volumes and find economic savings according to that scale. But I'm interested in your thoughts on scaling this down to a small scale and the recoverability of the catalyst. And my intention there is to think about, could this be adapted to recycling waste in space where there is a lot of organic material that could be recycled into fuel in that application. So I don't know if you've thought about scaling in the reduced direction.
Yeah, so we have looked to see how far we can reduce it. So far, I won't say we've concentrated directly on space for sort of going to the moon, but we've been looking for the ocean plastic side of things. But once we get it to that, we believe we can still get it smaller, and it'll just be obviously the outputs that will be affected by the main size of it. The catalyst, which is organic material with that, hopefully that could be taken up with a vehicle and used in space. It's nothing that would be dangerous to carry.
So 2 questions related to that. Does your catalyst get recycled, and what do you do with the coke ash that you showed in your video?
Okay, so with the coke ash at the moment, it can be used for various applications, so heating and such. At this present moment in time, what we have been using it for is on some furnaces that we have for our other equipment, and just using that to sort of start the heating process up with that. What we do see going forward is that sort of coke and product is still used in the UK as heating for some places. So it'd be looked at as a secondary product that could be sold on the market.
And Cheryl, you have a question?
Cheryl, you're muted.
You can't hear me?
We can hear you now.
How about now? Okay. So it's clear from the website, Skyrora does a lot of other kinds of businesses. Is this technology going to stay in the parent company? Or are you looking at spinning it off, or how are you going to kind of manage the two?
At present, we're looking to have Ecoscene move on to become its own entity out with the company. It'll probably be like an umbrella corporation. So it will sit below Skyrora as the branding, but be run as its own company.
Thank you.
Can you say something about your competition? What other approaches are people approaching to do this?
Certainly, I don't want to say there's no competition. I just don't think the competition has pushed in the same direction that we have. I am fully aware that there are other people taking plastics and rubber to fuels, but these are mostly low quality fuels. I've yet to come across anyone that's aiming towards fuel grade aviation or rocket fuel.
And do we have time for another question or two?
We do. Go ahead.
George Jensen. Robin?
We have time for some more questions.
So Derek, I'm more interested in the propellant from an end user standpoint, especially for like small satellites or other satellites. Are there any performance advantages or disadvantages the use of this fuel for smaller scale propulsion systems? Are there any handling advantages or greenness that the full supply chain and process for the small satellites ecosystem would be favorable about or be concerned about?
Yeah, certainly with that. So it's, as I said, at the moment, we're talking with a few satellite companies as well about taking this on board. And that is ranging from their own onboard propulsion. And some of them are actually speaking about asking us to supply Ecoscene for other vehicles, other launch vehicles that they launch on. And this is all to do with the new sort of green revolution that is being pushed along quite heavily within the new space market in the UK. So there is a big push for that purpose. But with it coming out as being potentially cheaper than alternatives that are available, a greener possibility. And if they're using similar to ourselves, Skyrora, which uses hydrogen peroxide and kerosene-based fuel for launches, it's, instead of burning off many different toxins, breaks down to water, carbon monoxide, carbon dioxide. And for a launch of our main vehicle, it works out about the same as a SUV in a week.
Okay. Because it's clearly the amount of propulsion, the amount of fuel used for these small sats is tiny. The cost savings aren't being realized there. But if we realize savings because the greenness of it and the handling of it and the lack of toxicity, that's where it'd be really attracted to my teams.
There is one thing we have had with recent checks with that, which we've had some feedback that it's got an extra bit of a kick to it compared to the normal kerosene, for example, or normal RP1. But because this is only the first couple of tests from the demonstration plant, I don't want to come out and say it's got 5% better kick to it or something like that. But it's something we have noticed on the tests we've done ourselves and hope to be able to publish in a paper or something in the near future.
Terrific. Great presentation.
All right, we have time for one more quick question. All right. Max, back to you.
Thank you, Derek. Really appreciate that. We are going to move on now to NeuroFlow and Matt Steiner.
Hi, my name is Chris Malero. I'm the co-founder and CEO of NeuroFlow. Before founding this company, I had the privilege of leading a platoon of soldiers. See, I'm a West Point graduate and deployed to Iraq in 2011, commanding 40 soldiers. Tragically, I had soldiers that lost their battle with depression, anxiety, and PTSD and ended up taking their own lives. Our investigation showed that not once did they go get that behavioral health help that was right there on base for them. The tragedy is that we know there are ways for them to get better.
NeuroFlow is a scalable care management solution for measurement-based behavioral health in all care settings. The award-winning company has quickly become a leader when it comes to empowering organizations to effectively measure and manage behavioral health. Available on iOS, Android, and mobile web, NeuroFlow helps you deliver personalized 24/7 content and resources to SOF operators to use in the field for supporting anxiety, depression, resiliency, sleep, and much more.
Hi, my name is Matthew Steiner, and I'm the Director of Government Affairs here at NeuroFlow. Now, before the COVID-19 pandemic, 1 in 4 people in our country suffered from a mental health illness. That means a quarter of my colleagues, and a quarter of your colleagues at NASA are as well. But sadly, 67% of our friends, coworkers, family members, they don't get the help that they need. Now, in this unprecedented era of COVID-19, during this pandemic, social distancing can make people feel so isolated and lonely, and can increase stress and anxiety. Fear and worry about your own health, the health of your loved ones, financial situation, your job, or your loss of support services you rely on. Changes in sleep or eating patterns, difficulty sleeping or concentrating, increased use of alcohol, and sadly other substances. Now, mental health is the single most expensive medical condition in the US and is multiplied when presented in a person with a chronic condition. The cost of care is estimated to be 2 times to 3 times higher for people with a comorbid behavioral health and chronic condition versus those with just a chronic condition alone. But beyond cost of the system, behavioral health is costly to employers. Depressive disorders contribute significantly to more sick days annually than any other condition, and people with comorbid mental health and medical conditions cost employers approximately twice as much as those with either condition alone. And now, more than ever, increased access to mental health services and support is paramount during this pandemic. Now, we all know there are too many gaps in mental health services, not enough behavioral health specialists, and geographic distance keeps some of us from accessing these services. But how can we utilize in technology not to replace human interaction, but to augment and supplement it? Just 8 months ago, at NeuroFlow, we had 40,000 individuals using our technology. And by the end of this year alone, we're gonna have 250,000. Last year alone, we raised over $11 million in funding from the nation's leading venture capital firms. We're also actively partnering with the leading provider systems like Jefferson Health and the US government through our partners at the Department of Defense and the US Department of Veterans Affairs. NeuroFlow also supports over 150 other organizations across leading health plans and providers to deliver digital evidence-based solutions to their end users. And as a trusted partner of the federal government, we have the unique ability and capability to sole source contract with any government entity. Now, NeuroFlow is a healthcare technology and analytics company enabling behavioral health access and engagement across a continuum of care, combining applied artificial intelligence, highly engaging mobile applications, and a care team dashboard. NeuroFlow helps leading insurance, healthcare, and government organizations deliver personalized evidence-based behavioral health solutions. Our suite of HIPAA-compliant, cloud-based tools simplifies remote monitoring and behavioral health integration in all care settings in order to improve outcomes, overall wellness, and cost of care. With NeuroFlow, organizations can finally bridge the gap between mental and physical health, help people feel better and faster. We customize our product for the unique needs and mission of the organizations we serve and partner with. We can customize for our airmen, we can customize for pain management clients for our providers in Oklahoma, and we can customize for our Space Force members. Leveraging extensive experience in user experience in behavioral economics, gamification, and remote monitoring. NeuroFlow users stay engaged and highly responsive with a turnkey program that supports the measurement and management of behavioral health conditions. NeuroFlow, we enable automated risk stratification, deliver validated assessments such as PHQ-9 for depression, GAD-7 for anxiety, and engage members with personalized 24/7 behavioral health resources and content. Coupled with an extensive offering of care coordination and coaching services, we stand as the only enterprise-grade solution that helps to reduce the cost of care without sacrificing member engagement and experience. Our user-facing app was developed by designers in industry with the consumer directly in mind. It's engaging, and each component of the application is evidence-based. You cannot provide help to folks if they are not engaged. Automated prompts remind employees to complete exercises, which increases compliance by 30%. Caring letters and access to 24/7 crisis resources reduces suicide risk by up to 50%. Now let's look at NASA Flight Director Sam as an example of how we're able to intervene for the betterment of Sam. Sam works at the Johnson Space Center in Houston, Texas, roughly 1,400 miles away from NASA headquarters in Washington, D.C. On the platform, a trigger. Sam's PHQ score, depression screening declines. So as a result, content is automatically assigned. An evidence-based depression 101 template is auto-assigned with education and cognitive behavioral therapy activities. Now, because real-time feedback is provided to the NASA care team, providers are alerted and conduct measurement-based care, allowing for more informed decisions. We're also able to gain population health insights. Data gathered from the entire NASA workforce provides real-time data for evaluation of programs and ongoing assessment of department mental wellness and resiliency. So Sam's experience is also how NeuroFlow is able to risk stratify. I'll give you an example. So with our work with the Philadelphia Fire Department, in the station say of 60, if 5% are scoring high for anxiety and depression, we're able then to identify those firemen and dedicate and allocate all the appropriate and necessary resources. Now, aside from helping your employees, it's about keeping NASA mission ready. On average, 27 workdays are lost in a year because of a mental health issue. Before COVID-19, 40% of employees felt burned out. Effective integration of mental health services overall saves $48.3 billion a year. Now at NeuroFlow, we have focused on improving behavioral health access and engagement with members. Our solution has achieved engagement of over 73% after the first month alone. And we have seen a reduction in the percent of NeuroFlow patients with a severe depression score that dropped to moderate to better. Now, again, regarding reduction in costs, there are many studies that show that those who are engaged in behavioral health condition have led to better management of their condition, which results in lower costs. Now, we're able to customize use cases for various populations. And for example, I want to give you a story about how we were able to intervene in a Philadelphia police officer's life. It's about maybe roughly a month ago. One of our care team managers received an urgent alert from a Philadelphia police officer. My fellow employee immediately reached out to that officer, provided resources, was able to schedule an appointment with the psychiatrist that day. That's just one example of the many examples that we have at NeuroFlow. We're literally intervening to save people's lives.
So I first found out about NeuroFlow from a colleague who said his clients were getting better faster. Getting better faster, I'm in. I contacted somebody from NeuroFlow and I, quickly got on board, and it's really exciting to see the significant advancements in people's progress and how it just works and sticks. As a clinician, there's only 1 hour a week that I'm with people, sometimes every other week that I'm with people. So what is everyone doing to monitor how things are going for them in the other 167 hours a week? And so this enables me to be a part of that process. They're able to be this self-monitoring coach and their own therapist, which is what any psychologist wants for their client, is to be able to be that monitoring person. You want to kind of teach the client how to do that for themselves, and NeuroFlow really provides that platform.
The need for innovative, technology-driven solutions in healthcare is at an all-time high. That's why the culture at NeuroFlow is one built around encouragement, having a healthy disregard for the impossible, and daring to be great. NeuroFlow's core values guide our mission of supporting care providers in their endless pursuit to help patients feel better, faster.
We look at healthcare problems very dynamically. Everyone brings a part of the solution to the table. We have data scientists, engineers, and product developers. We've teamed up with other healthcare systems from around the country, including health plans, and even patients, to come to the table, to collaborate and partner together so we can create the best, most effective tools for the patients that deserve them the most.
We have a trusted and passionate team of experienced individuals, and I feel really lucky every day to work here. I really kind of had that sense of service and mission I felt like in the Marines, and that really resonates here. Only 8 months ago, we had about 20 employees, 20 people on the team, and now we have over 50. We're growing exponentially. Partnering with NeuroFlow, from NASA's headquarters in Washington, D.C., you'll be able to keep a pulse and improve the mental health of your workforce. From the Kennedy Space Center at Cape Canaveral, Florida, the Johnson Space Center in Houston, Texas, to the Armstrong Flight Research Center at Edwards Air Base in California. No matter where your employees are at, NeuroFlow can help support your astronauts, engineers, and scientists safely deliver their mission at NASA while driving down healthcare costs and improving access no matter where they are. Thank you very much for your time.
All right, let's open it up for questions.
Yeah. Can you tell me on your survey, do you use physiological measurements also, or is it all a user response?
Thanks for the question. Yes, so the way the system works is there are clear questionnaires and activities that a user would go through, but we also use non-data, meaning if they don't log in or if they don't complete an activity, et cetera, all of that comes together to help influence what we consider our cumulative risk score, which goes back to the provider.
Warren, thanks for the information. How do you convince a skeptic, folks who don't see depression or anxiety in their lives, that this is worthwhile, or the employer that this is worthwhile? I used to ignore those health monitoring systems like this while I was at Boeing because they seem to be a waste of time to me. So how do you convince folks like me that this is worthwhile?
That's a really good question, and thank you for asking. So the thing about NeuroFlow that's really important to understand is this isn't an off-the-shelf wellness app that you would just go to the App Store and download or be made available as a service through an EAP. This is a solution that is driven through your provider. So there's a relationship that you have with your primary care provider where you'll actually be engaged at the initial onset. So when you take your initial, whether that's a PHQ, GAD-7, et cetera, through a primary care practitioner or a care team, that's what would trigger whether or not you need to be engaged in NeuroFlow. That baseline risk puts you into a stratified group, whether that's a low acuity, mid, or high. Low to rising risk is actually where NeuroFlow thrives. That's the area where people can control and start to engage in a self-care plan or program. As people get at a higher level of risk or higher level of acuity, we would actually coordinate and get them to the right level of care, whether that's a psychologist, a psychiatrist, right, some sort of other crisis line. And that's what you heard Matt mention in relation to a person who had actually been flagged and identified as someone who was in a position that could potentially hurt themselves. And we were able to rapidly get them the support they needed to avoid that event. So it's not something that you would maybe just grab off the shelf, and that's the big differentiator. Is this is actually flowing through your provider, which is where you have a trusted relationship already.
James, interesting platform. Quick question for you, just on top of what Dallas asked. So if your primary care provider is making the referral or recommendation to NeuroFlow, is that different than the normal process where they might refer you to a psychologist or a therapist? And what does that change look like?
Yeah, thanks. Another good question. So when you think about what we do is technology-enabled behavioral health integration, right? So on a typical PCP visit, you may or may not be screened for depression or anxiety, depending on what their workload looks like, and that's also dependent on how long you're in the office. So if you only have about a 5-minute, 10-minute appointment with your PCP, it's likely they're not going to use that time to focus on going through some sort of screener. And so the issue is that in a traditional sense, they're only going to screen those that they can that are in the office at that point in time. What we're able to do is scale, meaning they're able to actually invite their entire panel to NeuroFlow to take that assessment. So we have a couple of ways that we deliver assessments. One, through a tablet that's delivered, or manually on paper that's delivered through the PCP visit. Two, we can do telephonic outreach through our consumer engagement specialists. And then we have email, text, and the mobile app, which you saw in the video, which can actually invite and drive you to take that assessment. So what we're doing is we're actually increasing the amount of screenings that one primary care practitioner would do in any given year, so that we can increase the amount of people that are identified at risk and automatically deploy the resources. And if that's the NeuroFlow mobile app for self-care, or if that's the flag a care coordination or coach to get them into a higher level of care, that's when that would take place.
Thanks. We have a question from Ramona.
Yes, I'd like to understand some of the cost structure. I know what you're doing now is perhaps not the ultimate goal, but how does that work with regards to patient out-of-pocket costs, and whether you already have some insurance or that's the goal to get insurance coverage for this?
Sure. Thanks, Ramona. So, I'll two parts. I'll answer the question, then I'll ask you to clarify the first part, the ultimate goal of where we're going. But the answer as far as patient costs, the way we structure our fees is that this is covered either by the employer or the insurance organization as a benefit, and typically the provider would purchase this as a licensed solution. Again, not because it's a treatment. This is not what we do. We're actually a system that enables the scalable assessment, capacity and compliance that enables them to pursue the right level of care. So the care itself and the treatments, that's what would be billed back to the insurance company, and that's really what you would think you would need coverage for, the assessment, et cetera. And those are all covered by current CPT codes that exist today, whether that's for telemedicine, collaborative care, or some sort of CMS arrangement to cover assessments and wellness visits, et cetera.
Okay, I didn't realize. Well, I guess I didn't fully understand that your cost eventually to the insurance companies, or I guess maybe it's not eventually, it's already happening, is what you're saying, because it's already an accepted approach.
Right.
Okay.
So there are already billing codes, CPT codes that are designed for depression screening, or for, let's say you're a therapist and you write a medication, that would be, an ICD prescription. So the way it works is the treatments are actually still a standard medical treatment or clinical treatment. We're actually a technology to enable the scale in order to make that happen quicker. Now, the PCP does have the ability to, to submit, to bill for the assessments and whatnot. Those are still activities that they would take place. And NeuroFlow would actually enable the scale of that as well. So they're doing more assessments, which means they're able to bill more, et cetera.
Okay, thank you.
Ben? I'll come to you next, Julie.
Hey, James, this is Ben. I had a question around your kind of AI model. As we move more and more towards like machine learning for doing things like diagnosis, there's a real opportunity for unintended bias. Can you talk at all about like what your team's doing to kind of combat, kind of bringing bias into the process of mental health diagnosis?
That's a really good question. And what I'd say is, because we're using evidence-based standardized assessments to begin with, there's really no bias built into it. It's kind of a standardized structured score that exists today. Where you would start to see that bias is in the cumulative risk score that we start to put together as you see, the behaviors on the app, right? Did they do something, not do something? The good thing is mood tracking, sleep tracking, NLP built into journaling. Those things are all kind of built into the evidence. We're not reinventing the wheel there, right? We're using things that have been established in market already and integrating it into the experience. The non-actions, I think, is where there's some opportunity there. So if someone is assigned a program and they don't complete it, how much weight do we put to that given maybe they didn't have time, maybe there was an adverse event in their family, right, where they couldn't complete the journals or the assignments in the particular given amount of time, and is that actually affecting the risk score, right? I think that's where, to your point, there's some opportunity to continue doing that, but our engineers and product teams are consistently testing the methodology, testing the scores, and messing with it. So there's one of those things that's just kind of constant tweaking to try to perfect it. But we feel pretty confident in what we've done to give the provider the opportunity to say, hey, is this a situation that I should be worried about, or is this something that we can kind of allow to continue? We're not making that decision for them. We're providing them with the decision support so that they can get the information around their patient and make the best call in relation to that person's individual situation.
Thanks for that answer. I would really encourage you guys to make sure you're using a diverse training set. That's another really important piece, but thanks.
Yeah, thanks.
So I wrote down from the presentation that you currently have 40,000 users, and I think you said by the end of this year you'll have 250, or maybe it was the end of next year. But how do you arrive at this number, and what is your growth strategy and approach?
Yeah, thank you. Great question. So we have over 275,000 individuals under contract to serve this solution towards. That 40,000 number is kind of active on the platform today, meaning they're currently doing activities and completing assignments. So the model, though, as far as growth is concerned, is we have a direct sales model. So we work directly with the insurance providers, directly with the employers like the police and fire department. We work through AFWorks. We've just signed or just announced the part 2 of our AFWorks agreement. So we go directly to the providers. So we go directly to these folks and encourage them to make this available to their populations, and give them the resources they need in order to do behavioral health integration. So currently at 275, I think we've grown it, and we have Ellen on here to keep me honest. I think we've grown it at about 10x over the last year and a half or so, and continue just a really what I would consider a hockey stick trajectory. There's never been a better time for mental health as far as the industry is concerned, and you combine that with the telemedicine and virtual care environment, we're in a really good place organizationally to continue that trend.
All right, Cheryl.
So James, I have a background in NLP, and I also used to be the lead engineer at Red Brick Health. So I have some questions about the ecosystem above wellness. Like Red Brick Health, there's plenty of wellness things that somewhat tackle this problem, but also deal with diet, smoking cessation, et cetera, that either large employers or healthcare plans are already using. How do you compete with them? Are you planning to integrate with them or replace them by providing all of those features? And then are you integrating with downstream stuff like fitness trackers and all of that as well, or planning to?
Really great question. So it's important too, I think, to establish a baseline around the landscape of mental and behavioral health solutions in the market today, right? There are a lot of self-care solutions that exist. There are things that do just analytics. What we're doing is we're actually integrating into the provider workflow, which is slightly different. So yes, we integrate into the EHR. We bring this data, clinical decision support up to the clinical point of view so they can make decisions. And then we bring together the different practitioners, the behavioral health managers, and the telepsychiatrists together to do collaborative care. So slightly different than what you would consider in relation to a nutrition app or a mindfulness app or something that would be made available through like an EAP or a provider. So that this is slightly different. And as far as your question goes, is, in relation to integration, we're fully interoperable. So the idea is that because we do these things, this whole ecosystem, if you are currently using something that you consider to be, best in breed or best in class from a self-care perspective, we could certainly integrate with that. We do integrate with Fitbit and step trackers and things like that. So currently, there's nothing on the table as far as we're concerned. We just want to make sure people get the care and resources they need. But we know the best ecosystem, the best outcomes that we're able to deliver is when you use our entire ecosystem, right? But certainly open to integration and using whomever an organization may have so that they can optimize their IT investments.
Thank you.
All right, Harry, did you have a question?
Yeah, look, I really like the scalable assessments, but the target community you started with was the military. And unfortunately, I know from personal experience that many of them are very reluctant to admit to issues. And so how do you get buy-in to use the app where you answer the questions truthfully and not just get a low score?
That is a very, very good question. Stigma is certainly something that we recognize as a huge barrier in relation to mental health overall as an industry, right? And just to clarify, the majority of our business has been started through pain specialists, primary care, and behavioral health specialists at the bulk of the market. The military is probably one of our fastest growing segments of the business. And part of the value I think that the military and the DoD see in what we're doing is that because you're using this on your personal device, right? You're doing this in something that doesn't feel like you're being asked, are you going to hurt yourself? This is a consumer app experience. And so what we found is that because you're kind of doing it on your own, because this is seemingly less intimidating than, an assessment that you're checking boxes on in an office, people have a tendency to enjoy going through the process of using the app. I think that there's always a level of, honesty and dishonesty in relation to answering questions, whether that's through an app or in office. I think there's going to be a percentage of people that will naturally not want to disclose, how they're feeling. But, if we can catch even one person that's being truthful and give them the resources they need, I think we've done our job, right? I think the idea isn't to try to get 100% compliance. That's hopeful, right? That's what we'd like, but we recognize that that's not necessarily always going to be the case. But we're trying to help as many people as possible. So getting, the first step is getting that out in front of them, getting them assessed, giving them something that they can use to help monitor that kind of low acuity to mid acuity area, and then hopefully, deflect some of these higher risk or higher severity to a higher level of care.
Thank you. Rick, did you have a question?
You're muted, Rick.
That's better. Hey, James. So I think we're going to have a lot of fun at the impact table. So as somebody that lives with post-traumatic stress disorder, are you already incorporated in the VA? Because through my pain specialist and my psychologist and everybody else, I think I have 6 different apps that I'm supposed to be using.
Yes, I know.
So first off, are you in the VA system, and what does that look like?
First of all, I totally get it. And the VA does have multiple apps that they make available, and they have some really good ones. I think, our first pilot was actually with the VA. So we do have experience there. We're continuing to talk to multiple VAs across the country. We think we've got a solution that can kind of incorporate a lot of the things they're trying to accomplish into one thing. There's kind of app fatigue, if you will, across the industry, not just in this space. So being able to take a tool that integrates kind of all of the best of breed things that they're trying to bring together and deliver it in a way that is, built for scale and consumerism I think is what we're trying to convince them is the right thing to do. But yeah, the VA is very interested in what we're doing. They love the capabilities that we have. They simply don't have in those apps. And so they're very excited about what we might be able to bring to the table to hopefully collapse some of those 10 different things you have to use each day or each week.
Thank you, NeuroFlow. That ends the Q&A.
Sherman had a question.
Oh, Sherman, we have time for a quick one.
I was going to say I can wait to the impact tables. That's fine. Thank you, Harry. Though.
Thank you.
Thank you, everybody.
All right, Max, back to you.
Thank you, James. Really appreciate that. We have reached the time for our morning break, so we will continue on at 10:30. Hello and welcome back, everybody. We are now going to jump right into a presentation from Orbitless Drives.
Hi, my name is Rob Isis. I'm the CEO and co-founder of Orbitless Drives, the next generation of gearing. I look forward to spending the next 15 minutes or so with you to introduce you to a truly novel technology, one that can be applied in many applications in your everyday life. I look forward to answering your questions and look forward to hearing from you about how you can take advantage of this truly revolutionary technology.
Did you hear that high-pitched whine? It's a noise which you hear in many electric motor applications, like dentist drills, electric toothbrushes, e-bikes, or EVs, or electric vehicles. It's a common complaint and one of the key operating issues in the growing market for electric gear motors for all sorts of powertrains and actuators. From e-mobility to home automation, motion control in medical, defense, for air, land, and sea, basically anything that moves is part of the trend. For example, in each of the applications shown, there is some type of electric gear motor actuating or moving something, and they all have the requirement to be more efficient, more quiet, and generally smoother running. The problem is that the gear motor system has a flaw. While the electric motor is basically quiet and efficient, the gearhead that is used in many of these applications is relatively old technology, and is the main sources of loss, mechanical interferences, and vibrations in the system, resulting in relatively loud and inefficient gear motor systems. The traditional planetary drive, shown on the left, is made up of a ring gear in red, a sun gear in the middle, and the planets that engage quickly around the sun in 6 or more places. The ring gear also acts as an amplifier of the noise, which is caused by tooth engagement, which is then transmitted through the gears to the ring, which is also the housing. The Orbitless drive is a simple yet fundamental new gearing configuration. By removing the ring gear of the planetary system and replacing it with a secondary carrier, providing the output reaction, we have effectively halved the tooth engagement and frictions, reducing losses and internal speeds, resulting in the lowest noise and highest efficiency gearing configuration on the market. We started validating the technology in 2017 and have been working with independent gearing partners through various prototyping projects, as can be seen here with our first prototype done with Maxon Motors. We're also using a variety of advanced computer-aided simulation and modeling platforms to confirm the benefits. It's a continuing process, but as you can see, the early results are very positive. We've also been awarded multiple patents in the US, China, and Europe on our fundamental low-loss Orbitless Prime configuration and the high-ratio Orbitless Plus drive. The unique thing about these patents is that they were accepted with no office actions and no prior art on the technology, confirming that it's truly a unique solution. We also have a series of enhancements and other variations in the patent pipeline in all jurisdictions. Our licensing-based business model enables customers to license this core IP based on the geography, market, or whatever their business needs are. Further validation continues as we utilize the latest computer-aided engineering tools for various analysis, such as the Simulation X tool by ESI, which allowed us to identify and isolate the noise profile of the Orbitless against a planetary drive, showing our low-frequency noise versus the high-pitched whine you hear in a planetary system. We've also been using Romax Technologies' Nexus platform to further our understanding of the Orbitless drive's unique kinematics. We continue to perform a variety of design optimizations, particularly around bearing analysis, deflections, and misalignment management. Finally, we are working with leading gearbox manufacturers to build high-quality prototypes. For example, this unit is our most recent build with Framo Morat, and we'll be testing on state-of-the-art systems to really understand the performance of the Orbitless drive. And just like any other gearing technology, the Orbitless drive is really a platform technology versus a single solution, and can be configured in a number of ways to meet the unique application requirements of each customer. Whether it's noise reduction, higher efficiency, or a more compact high-ratio design, We take the customer's application requirements and design a unique solution to meet their needs. At the same time, we are working on some standard reference designs that meet some of the more generic low-noise gearhead needs. For example, here are 3 solution configurations that we are focusing on due to their very unique benefits. The Orbitoless Prime, which is our core technology for low noise, high efficiency. The Orbitoless Plus, using belts or chains, a truly unique high ratio option. And our Orbitoless Gearless, which is, as the name implies, a no gear 2-to-1 reducer or increaser that will make even the most seasoned engineers scratch their head. When it comes to NASA and the applications that are relevant, we have a lot of ideas of where an Orbitoless can benefit applications in space due to their inherent benefits of low NVH or noise, vibration, and harshness, high efficiencies, and the ability to use alternate materials and some significant lubrication benefits. Electric gear motors are used as actuators to move satellite arms and panels, and in rover-like autonomous vehicles for powertrains like in-wheel drive systems, or actuators that enable arms on the vehicle to extend their reach. We also see a lot of opportunity in other air, land, and sea, including defense and industrial applications. And we're really just scratching the surface in these application areas and welcome your questions on where an Orbitoless drive can fit in your product. As for current projects underway, we have a number of paid projects in the prototyping phase of development that are specific to customers' unique applications. From EV drives and actuators for doors and liftgates in the automotive market, to e-brakes for trains, robotic vacuums for homes, and medical device microdrives, there's a lot going on. As a more detailed example, we recently got approached by an electric motor manufacturer called Aurora Industrial Machines that is launching a new class of electric machines that had a particular need to have a very high efficient 2-to-1 increaser with a close to inline shaft. Orbitoless offered a very unique solution for this application. We're partnering with them on the design, and they will be testing the solution with an end-user customer once the prototype is built shortly. Our model is to license our IP and designs to customers, which can be direct or through third-party manufacturing partners. This follows our Orbitoless development program model, where we have a very structured path to take customers from the idea and innovation stage through an iterative design and simulation phase, a prototyping stage with various functional and performance prototypes done, then preparing the final design for manufacturing and ultimately mass production. We utilize the latest computer-aided engineering technologies either internally or through a network of industry partners. How are we getting all this done? With a great team. We're building both an internal team and an ecosystem of global industry experts and design partners to commercialize this exciting technology. My co-founder and partner, Dr. Leo Stocco, is the inventor of the technology. He did his PhD in electromechanical optimization around robotic systems and is still a current lecturer at the University of British Columbia. The idea came to him when thinking about how to optimize and get rid of the hard-to-manufacture and expensive ring gear in a planetary drive. Another key member of the team is Laurent Belil, who is designing both gearing solutions and some CAA tools to assist in the specific development of Orbitoless drives. In addition, we are building out a network of gearing-focused design partners from the automotive, aerospace, and industrial markets to implement Orbitoless for their customers. Tech is based in Switzerland, has years of F1 and aerospace experience, and Vibon Lee from Advanced Mobility Products, based in Toronto, has been involved in automotive and aero application designs and builds for 20 years plus. Finally, we are adding industry veterans to our board of advisors, including John Jennings, who is currently Global Technology Director for Means Corp, a leading automotive drive component manufacturer, and in the past held similar roles at Eaton and Linamar. This ecosystem extends beyond our design partners and is really fundamental to our business model of primarily IP licensing with some design services. We work with industry organizations, speaking at conferences to educate the market on Orbitoless. We're also closely working with CAA design and simulation tool partners to get them to add support for the unique Orbitoless kinematics to ensure a robust design path. We see our main customers as the gearbox manufacturers, who are generally working with end-user product companies to spec out the requirements and go build modules in the form of gearheads or gear motors that embed into the product companies that most of you know. For us, it's really about building partnerships in all segments of the market, and we're really just getting started. So now you may be asking yourself, how big is this market? The reality is it's hard to put an exact number on it because it is very fragmented with various sizes, materials, power scales, niches, and mainstream markets. Various estimates put the TAM, or the total addressable market, well over $250 billion, and it's estimated that 25% of it utilizes planetary drives, with parallel access drives being the leader and niche technologies like harmonic drives taking smaller percentages. We estimate that the SAM, or the service addressable market, for Orbilis to be in the range of 10%. And based on a typical royalty rates in this market of between 2 to 10%, it's a very healthy opportunity. So where are we today? Well, hardware takes time. We started this journey in 2016 when we started to truly understand the technology with first prototypes built and started to define which markets it applied to, as well as showing the basic concept to a lot of industry people. From 2017 to 2019, we focused on validation and education of the technology, building multiple prototypes with industry partners, showing off the concepts at trade events, winning numerous innovation technology awards at SAE's World Congress via the GAMIC program, Startup Canada's Export Award for BC, and many others. We also did many international trips to key market areas of China, Germany, Detroit, and others. We also presented papers and findings to a number of international industry and partner events during this time. We also participated in a number of local accelerator programs, including Creative Destruction Labs and in the Hatch program at the University of British Columbia's Entrepreneurship Program. And a number of international pitch events and accelerator programs, including TUSTAR in China, Startup Autobahn in Stuttgart, and most recently Tech Founders in Munich, which paired us with a corporate sponsor, Norbremse, who we're currently doing a prototype project with. We've also raised some angel funds from a number of top local angel groups, as well as participated in some Government of Canada technology funding programs, which has given us access to customers, mentors, partners, and the dollars at an international level. Results of these programs have led to multiple paid active projects for specific applications as discussed. Ultimately, this will lead to volume production and license revenue in multiple markets.
Thanks for your attention. We hope you got some appreciation for this exciting technology and the numerous applications in the wide variety of markets that Orbilis can fit. Whether in space or on the ground, the future is bright for Orbilis. We have our patents, our team, have great validation, and are really understanding the true applications that Orbilis can benefit the most. What do we need next? Well, it's customers. We need customers that are looking for high efficiency, low noise gearheads for their electric motor applications. Secondly, we need partners to help design and actually build those systems. And thirdly, we need strategic investors, ones that really understand hardware, can take the technology and apply it in their own use, but also for their customers as well. We look forward to working with you all and hearing from you for your questions. Thank you and have a great day.
All right, thank you. Let's open it up for questions.
So, I was very happy to hear that you make quieter. Can you comment on its impact on the lifetime of the gears? And are the failure modes similar to a traditional gear?
Yeah, so basically the quietness comes obviously from the gear engagement, the reduction in the gear engagement. Now, from a durability perspective, what we do is using all the simulation tools, we'll basically build a gearbox based on what the desired gearbox durability is going to be. So we can change and use whatever materials that are out there to meet the durability requirement. Right. So in general, it's really about that customization of the design to suit the durability requirement. So if it's a really long-term one, we'll use harder materials and so on. Right. So that's basically how that generally works. There's no real single answer to that question.
But you have done lifetime measurements on something to show that.
Yeah, well, okay. We have done some on the original prototypes we did some like 1,000-hour tests and those sort of things. And what it showed was there was no, discernible wear problems in those initial tests, right? Generally, those are initial prototypes. Once we get into actual products for a customer, we'll continue to do different tests on their physical or their final applications. Right?
So for lubricants, are the lubricants be the same as what you would use currently?
We're experimenting with that right now. We're doing a project right now, I mentioned with Norbremse for a rail of e-brake solution where we're using a traditional lubrication that would be used in a planetary. And the initial results are already showing that the lubrication is treated much gentler than it is in a planetary. So that's allowing us to kind of play with lubrications to potentially use something different for a wider range of applications. And it's because it doesn't really mesh the gears as much, so it doesn't disturb the lubrication as much as it does in, say, a traditional planetary.
Thank you.
Next question.
This is from Mona. Hi. I'd like to understand a little bit more about your gearless design. You didn't speak about that too much. I'm wondering about the value it could bring to us when we deal with a very harsh, dusty environment like we imagine on the lunar surface. I don't know if the gearbox would protect it, but just share there about that.
Sure. The gearless solution that we talk about is a very unique solution. It's limited in terms of where it fits from the perspective of applications because it's limited to a 2-to-1 increaser or decreaser. Where it fits really good is when you were talking about high-speed motors, and the motors are getting higher and higher speed. To do that initial reduction to half the speed, so then you can use a more traditional gearbox on it. That technology is literally brand new, and we're just starting to do the sort of analysis of it to really understand its core operating parameters. But it's really a unique solution, and for the things like you mentioned, dust and other stuff, because you're getting rid of the gears, we think it has a lot of potential for a lot of applications. But more to be done on that, and if there's interest, happy to engage with somebody on it. So,
thank you,
Sherman.
Yes, I wanted to get an understanding of the heat benefits that are brought about from your drive. I'm thinking about getting things out of the atmosphere and things being lighter, and not needing as much cooling equipment on because of the heat benefits you may bring about.
Sure. Yeah, I mean, heat has to do with sort of the engagement again and the speed of the gears they're going. Because we actually have that lower engagement and lower internal, what's called pitch velocity, or internal gear speeds, we do suspect that heat will be reduced because of that. Now, again, some of those are in tests that we're doing right now. We haven't done a lot of testing on that because we're at the stage now where we've taken these design concepts, done some virtual prototyping, and we're just physically building some of these application-specific designs now. So they're in testing right now. We're seeing some results of that, but we don't have definitive answers on that yet, but we're getting close to having some really good data points on that. But it should be better. Yeah.
Next question.
Yeah, Robert, for your prototypes, do you have comparable planetary gear designs to test side by side for actual comparisons?
Yeah, exactly. So that's what most of them are done. The first one we did that I showed with Max on, this little guy here, was tested against an off-the-shelf, fully optimized planetary drive. And this was our initial prototype that we did, again, with Max on, so a high-quality builder. And that's where we showed the initial performance increase in terms of efficiencies and the lower noise. So we're actually comparing against a years-old, over-engineered, highly optimized planetary drive to our first prototype Orbilis, and we got good results. So that's obviously led us to do more, right? And just about every product we're doing now is comparing against some traditional gearing, whether it's or planetary and just the regular parallel axis drive. Everybody's always comparing us to sort of the incumbent technology.
All right. Any other questions?
Very quickly, Robert, this is Kurt. I started out life as a gearhead, so I really tried to dive into that and remember how to figure out the kinematics of gears. So I'm curious if you can just say a little bit about the relative efficiencies of your approach to the harmonic drives. I mean, a lot of the comparison has been with the planetary drives, and it's a clear mass savings there, but the but the harmonic drives are similar in some respects to what you have.
Yeah, so harmonic drives are really focused. There's been a relatively new technology as well, really focused at very sort of higher ratio, compact density type applications, compact power density applications. So high ratio being 50 to 100 to 1 is a sweet spot for harmonic. They have traditionally been relatively expensive and reasonable efficiencies, but not wonderful efficiencies. But really focused on what's called low backlash, which is really good for robotics applications where you need a very precise sort of movement, right? Our orbitless Prime is really not a competitor to that because it doesn't fit that sort of ratio range. Our orbitless Plus drive, which is our high ratio compact design, we think that there's some applications there where it won't necessarily compete with the high end of the harmonic market, but probably in the sort of, if you need a compact ratio, 25, 50 to 1 gearhead with, compact design, we can fit in there. So what we think is that we're just another tool in the gearbox designer's toolbox that's going to fit a segment of the market, right? And we're just trying to identify what that product market fit is for each of the different technologies. And that's why we say we're not going to replace everything, but we're going to slot in and fit in certain applications where we can really show off some good benefits, right? Against all those other incumbents.
Yeah, very helpful. Thank you.
Yeah.
How long do you think it'll take you to do market penetration?
So we've got, again, the first couple of years was really about validation and trying to uncover which applications made sense. Over the last 6 months, and again, we've been slowed a little bit by COVID just because getting things built in this time frame has been very difficult. But we've got literally 4 or 5 projects coming online now with application-specific builds, and those ones are being tested over the next literally, month and a half, 2 months. And then we'll have some real proof point application-specific designs that we can then start to sell to the market. Generally in the gear world, nothing is really off the shelf. It's usually off-the-shelf concept with a little bit of tweak here and there. So it just depends on the application space we're dealing in. In automotive, it could take 2 years to come up from an idea to a build. In a home automation thing, it might be 6 months. So we expect to see some products coming to market over the next sort of 6 months, right, with license agreements.
Anyone else? We still have a few minutes.
If nobody else has a question, I have a question about whether or not you guys have looked at either drone markets or electric aircraft propulsion markets. I know that one concern is that as drone traffic increases, noise from drone traffic is a big deal. And if you're, I'm not sure exactly how the noise hashes out in terms of what's coming off the airframe and what's coming out of the gearbox. I don't know what the drivers are there, but noise is going to be a big concern for high volume unmanned traffic.
Sure. So the thing in drones that people always look to us and say, well, you got to make a drone quieter. And the challenge is a drone is generally a direct drive solution, meaning it's just electric motor with the fan, basically, or the blades. So there's no gearing in there traditionally in most of those motors. Where the gears are used in a drone is more for the camera articulation and such, which doesn't make a lot of noise relative to the actual, blade movement. So that's more of a blade technology sort of opportunity versus a gear reduction opportunity. So unfortunately, we don't really address that market specifically. However, we are looking at some more efficient sort of propulsion systems, like you said, for other aircraft and such, that are starting to use planetary drives or that have been using planetary drives, and we think there's an opportunity for that with our orbitless drives. But that's still early sort of thoughts and concepts on that.
How far along have you been able to get with meeting certain engineering standards, and also have you looked into getting on the US GSA schedule for purchase?
Yeah, so we have done a little. The design or the standards that we follow are pretty much all the ISO or the what's called the AGMA, the American Gear Manufacturing Association standards. So in the design that we're doing, all the tools that we're using already have those standards sort of in there. So we don't do anything funky from a gear or material perspective. It's all pretty standard. It's just a reconfiguration of things, so it's easy to meet those sort of standards, right? What was the second question again? Sorry.
About the GSA schedule, the government.
Yeah. So we have not done much there yet, and really are looking forward to going down that path. Most of our customer projects thus far have been in either Europe, in the German market, which is big in the sort of mechanical industrial world. We've done a bunch in the automotive space, basically out of Detroit, but we really haven't kind of broached that into the government world yet. But ideally, through this and other recent initiatives, we can get in there and start to show off the product in that area.
That would be critical to make inroads on that side of the fence.
Absolutely.
Thank you.
Anyone else?
Robert, this is Ben. Question for the kind of like renewable energy market. Some of the largest and most like high-wire orbital gearboxes are in windmills, and you guys kind of showed that in your video.
Yep.
Is that a like target market for you guys? It's a lot bigger, obviously, scaled up from what you're doing now. But can you talk about that a little bit?
Yeah, sure. So that's a great question. We actually, when we first introduced orbitless, everybody kind of pointed to the wind market saying they've got a big problem, they got big gears, you should go there. But you're right, it's a big scale opportunity and lots of torques and speeds and stuff that we didn't want to jump into first. However, since that time, we've actually been approached by a large wind power company that are quite interested in the technology, and we're sort of in initial discussions about some potential projects to do some due diligence and try to design a unit looking at their traditional gear structure, because they usually use different types of gearing stages within their systems, to replace one of them with an orbitless for a more efficient system there. So we're starting that discussion with an interested strategic partner that has a real focused application. And that's kind of what our business model is. It's trying to find those strategic partners that have a deep understanding of their particular gear need, and then they see some benefit in orbitless, and then work together to try to develop it into a formal solution. And that's why we're really looking for strategic partners, that will help us design, and so we can work with their design team to design something specific to their application space.
All right. Well, if that's all of the questions, Max, I will go back to you.
Great. Thanks, everyone.
Thank you, Robert. We are going to move on now to our last presentation of the morning from Mojo Vision.
Modern technology promises to make us more knowledgeable, more efficient, and more connected. But does it? In surrounding ourselves with screens and devices, maybe we're losing something of ourselves. Imagine having the freedom to walk away from our screens. Would we see differently? Could we see more clearly? Or would we just begin to see? We see a future where computing becomes invisible, where technology fades away. The important thing is finding an edge, even in friendly competition. Imagine an augmented reality platform that lets you move freely. A truly mobile device that allows you to see unobstructed. A device that organically maps your own content right into the world. What if you could confidently explore new cultures and languages, free from digital disruptions? Free to truly see eye to eye, forging lasting human connections. Imagine a world of seamless navigation, where you no longer need to keep your eyes glued to a map, What if you could feel like a local wherever you go? What if, with just a look, you could discover more than the eye can see? Just imagine the possibilities if you could truly interact with the world with that same look. It will help us provide better care for one another, allowing us to connect in crucial moments, providing vital information in an instant. It's hard to imagine our lives without a device in our hands. But imagine if you could replace the screens that pull your focus away with something that elevates the world around you. We don't have to imagine. We are turning science fiction into fact. An augmented reality smart contact lens. What will you see? Eyes up.
Over the past 60 years, we've seen incredible leaps in computing technology. The introduction of mainframe computers, mini computers, personal computers, the explosive growth of the internet and the World Wide Web, the freedom and versatility of mobile devices. Now we find ourselves at the beginning of the next wave of computing. With sales of smartphones beginning to plateau, we are seriously asking ourselves, what's next? What is that next wave going to be? Many people think that this will be some form of augmented reality, virtual reality, or mixed reality, where the physical and the digital worlds begin to merge. And we at Mojo agree. Succeeding the smartphone will be something even more powerful, more wearable, and more personal. Of course, the expectations for the future of computing are incredibly high. Popular culture and Hollywood have shown us a world where computing is ubiquitous, where there are no physical screens or devices, and you just wave your hands or speak naturally and information just appears. But the reality today is completely different. The state of the art in AR and VR is still big, bulky goggles or glasses. These products contain incredible technologies and are proving very useful for many specific use cases. But in their current form, they're not going to take the place of the smartphone in your pocket anytime soon. I started my Mojo Vision journey in 2011. I developed cataracts and I underwent surgery to implant devices called intraocular lenses in my eyes to restore my cloudy vision. I woke up from the operation and I could immediately see, but I also started to discover some deficiencies in my vision. I thought, it's the 21st century. Why don't I have Steve Austin's bionic vision like in the 1970s TV show, The $6 Million Man? And that's when my idea for Mojo Lens was born. We founded Mojo Vision because we knew we could build something that would fundamentally change how we access, see, and interact with information.
Put Mojo Lens on in the morning and throughout your day, you will have access to timely information without losing focus on the world around you. Mojo Lens is designed not to bombard you with data, but to elevate your vision by providing the information you need exactly when it's needed, all while letting you look like yourself. When it's not in use, the technology just fades away. We call this concept invisible computing. Ultimately, Mojo Lens is for consumers who are looking for the benefits of invisible computing. A hands-free, eyes-up experience, but building the consumer market will take time, so we're targeting the first Mojo Lens to address unmet needs in vertical markets, where its ability to deliver mission-critical information will be highly valued. Imagine the firefighter who can see where they are in a smoky building, or an ER doctor who can quickly triage an emergency, or the repair technician who needs heads-up access to checklists and schematics. But who's going to want to wear Mojo Lens? We don't believe that smart glasses and smart contact lenses are an either-or proposition. For Mojo, our initial customers will be the 130 million people across the 16 countries that we are targeting who already wear contact lenses. People who have chosen those lenses so that they can look like themselves.
Mojo's invisible computing solution will be a platform that gives you everyday superpowers and an invisible edge throughout your day. But before it does any of that, it first has to be a great contact lens that improves your natural vision even when it's off. Mojo Lens built-in display will give you augmented reality wherever you look. There are no field of view limitations because the lens projects content wherever you're looking. It even works with your eyes closed, putting you into an instant VR world.
The applications are nearly limitless, from being able to see in the dark or low light situations, to augmenting your memory with instant information, showing you real-time translations, or giving you a virtual teleprompter. While augmented reality in a contact lens is certainly exciting, that's just the beginning. One of our first medical applications is using AR overlays like edge detection and contrast enhancements to help people with vision impairments such as glaucoma and macular degeneration. But it doesn't stop there. By building a wearable platform on the eye that has power and data, we're opening the door to a long and exciting list of health and wellness features that either we or our partners could implement. Diagnostic tools, real-time disease monitoring, and biometric feedback. These are all possibilities we intend to explore as we mature the Mojo platform. Which brings us to why we're here today. Our ask of NASA is to consider integrating the Mojo Lens platform into NASA's upcoming space missions. We believe that ambitious programs like Artemis deserve a 21st century computing solution that can deliver unique advantages over other devices. Besides its ability to deliver mission-critical information that literally cannot be missed, even with your eyes closed, Mojo Lens will easily fit inside the helmets of our future astronauts and do so with minimal weight, bulk, or battery. It can be used hands-free, controlled with your voice or just your eyes, and it will reduce the need for many of the displays and screens that add costly weight to every mission. Many of the use cases we envision are dual use. They can be developed to help astronauts in space just as they can help consumers here on Earth. For example, Mojo Lens will be able to assist with day-to-day operations, providing step-by-step checklists for experiments and maintenance, controlling objects and equipment within the craft, as well as display critical flight and EVA task information. It can also be used for remote assistance, allowing an expert on Earth or inside a spacecraft or habitat to see what the astronaut sees and to assist them in their important maintenance or medical tasks. This capability will also be very useful for training exercises and ergonomics to study where astronauts are looking when completing different assignments. Lastly, Mojo Lens can be used to perform continuous health monitoring and to detect changes in mental health of the wearer, critical for long and arduous missions. Having constant psychological biometrics for all crew members can help controllers monitor intercrew dynamics and influence emerging conflicts before they erupt.
Building the world's first AR contact lens is a systems engineering problem, and therefore we've had to innovate in many different areas. For example, displays, optics, wireless communications, sensors, and materials, all while keeping the system small, low power, and of course safe. We embed all of our smart components into a time-tested contact lens platform called a scleral lens. A scleral lens rests on the white part of your eye, and it doesn't touch your cornea. Now what we do is we custom fit each lens to your eye so that it's extremely comfortable to wear and it doesn't rotate or slip on the eye. We've also patented a method that maximizes the oxygen delivered to your eye, which is another critical element of contact lens comfort and eye health. The Mojo Lens includes thin film, biosafe batteries to power the system, as well as motion sensors to enable the world's most accurate eye tracking. We've also developed an extremely low power image sensor that's used for computer vision and scene detection. But at the heart of the Mojo Lens is the world's smallest and densest dynamic display. The pixel-to-pixel spacing in our display is only 1.8 microns, giving it a density of 14,000 pixels per inch. With this, we can display crisp text, photos, and video in a package that's less than 0.5 millimeter in diameter. Now, on top of that display, we put an elegantly complex multi-surface micro-optic that we make out of a single piece of plastic. This micro-optic focuses light from the display directly onto the retina. So sometimes we get asked, won't the system block your natural vision? And the answer is, of course, no. It turns out that the display is so small and close to your eye that your eye essentially looks around the display. It's the same principle at work in a Cassegrain telescope like the Hubble. Our current system delivers a monochrome green image, but we're also working on a color display for next generation products. Mojo Lens is designed to be worn on both eyes. This gives you stereoscopic vision, and each lens communicates to a Mojo designed accessory where we put the compute and the network interfaces. For example, the Mojo accessory can wirelessly connect to your smartphone or to the cloud. The accessory is also where our software applications reside. It's worn near the head, and in our first generation product, the accessory can be built into a helmet or a hat, safety glasses, or even a necklace. One interesting function that the accessory also serves is to capture the eye motion data from the contact lenses, compute the updated digital view based on the user's new eye position, and then send that view back to the lenses, all in under 10 milliseconds. This ensures that the AR content stays still in the real world, even as you move your eyes. We are often asked, how do you control Mojo Lens? And the answer is with your eyes. It turns out that your eye is an extremely accurate pointing device. With our built-in eye tracking in each lens, we believe we've unlocked the ultimate hands-free user interface. With just a glance, you can select tools and access content effortlessly.
Over the past several years, the Mojo team has been hard at work taking the principles and learnings of our early research to develop successive generations of Mojo Lens. Starting in late 2019, over 10 Mojo employees have worn and tested the Mojo Lens, and now we are working on the next generation prototype, which includes all the system elements we've discussed today. Our plan is to optimize that feature-complete lens and lock our first product for clinical trials within just a few years. Since all contact lenses are classified as medical devices by the FDA, we are building the quality systems and culture necessary to ensure our lens meets or exceeds safety standards for all-day use. Mojo Lens was designated as a breakthrough device by the FDA because of its potential to help people with vision impairments regain their mobility and independence. This designation allows us to actively engage with the FDA throughout the development process and reduce program risk. Creating a safe product is just one element of building trust with our customers. We also know that we have to safeguard their privacy and build secure systems they can rely on. We take these challenges very seriously and have already begun reaching out to the optometric community and to thought leaders in ethics who can help guide our design decisions.
Mojo Vision was founded just 5 years ago, and in that short period of time, we've made tremendous progress towards inventing the future of invisible computing. As a successful serial entrepreneur, I've learned that one of the key secrets to success is assembling and enabling an incredible team if you want to solve really complex problems. The Mojo team is now over 100 employees from a wide range of world-class organizations. Most are engineers, 1/3 of which have PhDs. Our team has innovated in many different areas and filed over 110 patents across every aspect of our technology stack. We've been fortunate to have raised over $159 million in private funding from some of the world's leading venture capital and strategic investors, and we're beginning to see momentum in vertical markets, including government agencies, with contracts totaling over $15 million. And all of our efforts are managed by an all-star executive team that has built and shipped groundbreaking technologies, consumer products, and medical devices that we all depend on and enjoy every day. I like to say, if it doesn't break the laws of physics, then it's possible. And proving that something like Mojo Lens is possible motivates us each and every day to invent the future. Ultimately, we believe that we can help people achieve their potential without sacrificing their humanity. That's the promise of invisible computing. Thank you very much for your time today. Eyes up.
All right, thank you very much, Mojo. Let's open up the questions.
I'll start. John Carr here from Marshall. I was curious, a great technology for sure. I was curious how much of the core subsystem technology, the batteries, the image sensor, et cetera, is your IP, and how much of it is licensed or purchased from somebody else?
Yeah, that's a great question. We've had to build a lot of the technology. We have our own ASIC team. The image sensor is our own custom design. The wireless link, the radio is all custom. But we also try to work with other companies wherever we can because there's plenty to do here. So we work with other companies on the batteries and some of the other motion sensors, for example. If you have another technology that you think could fit in here, we'd love to put it in. It doesn't have to be all our stuff.
I had a question on contact. Are they the same size as normal contacts, or how much bigger are they, and are they comfortable? I mean, you said that you fit them, but contact, or people have trouble wearing them?
Yeah, that's a great question. So, for my own journey in coming to contact lenses, contact lenses are not my background. I've come to understand there is not really any such thing as a normal contact lens. There are many different types of contact lenses, and those different types solve different kinds of problems. So a scleral lens is a type of contact that millions of people wear. When you say normal, you probably refer to like a daily soft disposable contact lens. So this is clearly different than that, but it's still a high volume contact lens platform that corrects people's astigmatism, for example, or if you have keratoconus and you have a misshapen cornea, this is another kind of contact lens you would wear. What we do is we make that contact lens, the shape of it, fit the shape of your eye. Your eye is actually not a sphere. It's more like my fist. It has bumps and weird shape profile to it. So when you make a contact lens that actually fits the shape of your eye, then there aren't places that dig in or feel bad. It's very comfortable. So yes, these are comfortable lenses. They may not be the type that you are most familiar with, but many people wear them on a daily basis.
So you are a hardware company, as if I understand it. Who is doing the software for all the VR tools that you described?
Yeah, we have historically to date been hardware centric, because that's where a lot of the hard problem was. You say you're going to make a smart contact lens, that's mostly, physics, engineering, applied physics, that sort of thing, right? And the contact lens manufacturing side of this. But now that we've matured on all that hardware, we are now starting to delve into software very deeply. So we've recently hired a guy who's our SVP of software, and he's building up a software team as we speak. And I imagine that over the next several years, the weight of our company will shift heavily towards software in terms of total headcount.
All right, we actually have a question from one of the live streams asking what happens if there is a cyber attack / virus and the virus causes, for example, high intensity lighting. Does your eyesight go?
Yeah, I'm gonna also ask Steve Sinclair to answer that one, but we are specifically engineering this contact lens to not be able to hurt you, that it can't put out the kinds of energy, light level, or what have you to be able to hurt you. So even if we could imagine some mode, it can't hurt you. Some mode where there's a virus, it cannot harm you. Steve, you want to add to that?
Yeah, I would just say that, as we build out the ecosystem for this platform, it'll have an app ecosystem that is very similar to smartphones today, where we will be able to understand what people are trying to put on the platform, be able to do app reviews before they become part of the platform. So we'll be able to catch issues like that as well.
Any other questions?
Yeah, I'd like to go back to the apps. Sorry, I didn't mean. Are you open to third-party people developing apps for your device, or is it you want to do it all in-house?
We're very open to. We want third-party apps. Steve, you want to take that one again?
Sure. So yeah, we're definitely interested in building an app ecosystem that third-party developers can write apps for. There's no way to possibly guess all the different use cases that people are going to want to use this product for. And so opening it up similar to, again, the platforms that we're familiar with is a good move. Early on, we're going to be very measured on who we partner with for applications. They're going to be very specific vertical apps, and we may write many of those ourselves to start with to work out kinks in our SDK and make sure that it's a solid platform, which is not unlike how the iPhone brought its app store to market a couple years after the first product.
So the first one is, could you talk a little bit more about how it's powered and how it gets data and how much bandwidth the lens has? And then also, I think I asked this for another company doing AR. It's not possible to get like a blue screen of death in front of your eyes, right? Or you wouldn't be able to see anything?
Working backwards, you can always make it stop. Mm-hmm. Our view of the future here is not that there's content and stuff up around you all the time. We actually want to try to allow us each to be more human instead of kind of what we like to think of as less human with our eyes down in our mobile phones all the time. So we want to get you back up into the real world and only show you information when you want it, and you can always make it go away. Working backwards, so that's the last question I think you asked there. The power and data, we have very tiny micro batteries that go and power the system. That's how the energy is delivered to the rest of the system. The system takes very little power. We have spent a lot of time engineering ultra low power chip technologies, ultra low power wireless link. We had to build our own wireless link and our own radios in order to accomplish the power and speed trade-off that we needed, and size. You can imagine that if we go and try to buy a Wi-Fi chip or a Bluetooth chip or something and stick it in the contact lens, those things are just too power hungry and too large to be able to fit in there. So our data rates are in the tens of megabits per second, like 40 megabits per second uplink to the contact lens. So there's quite a lot of data there to push all the viewable content and sensor data back and forth across the link. Did I answer all the questions, or was there another one in there?
Nope. That's it. I just have a quick follow-up on being able to make it stop. What if you're driving or something? What's the mechanism for emergency, turning off the lens?
So there are a number of mechanisms that we're still working through, right? We're kind of pre-product, so we're still trying to eat our own dog food and figure out all the different methodologies. But as we've mentioned in the video, one of the ways to control the lens is with your eyes. And so there is a way to, with one glance, dismiss anything that's in front of you. That's one of the concepts that we're prototyping. But there are also other concepts that involve, physical mechanisms. You can just flip a switch or push a button and just disengage, make it stop for a period of time.
Thank you.
Yeah.
So will there always be an on-off switch visible to the user?
As I said, these are kind of prototyping concepts. Our view is that the accessory device that you wear should be very inconspicuous. We're going for trying to get towards social transparency. It could be something like a necklace, as we mentioned in the video, that sits underneath your shirt, and so is not readily visible. So I'd like to leave that answer a little open for the moment.
Okay, so I was referring to an on-off switch in the vision, so that you control it with your eye. Would there always be something you could see to look at to turn it back on?
One of the really fun things we've discovered about working on this is that with fantastic eye tracking and a display all working together, you can really rethink the user interface and rethink the whole concept of buttons and activation, and how you bring things up with your eyes and how you dismiss them and how you select them. So I think the concepts of there has to be a button in order to make something happen also kind of go away. So suffice it to say, our view is you should always be able to make it stop. You should always be able to make it go away, and focus on the real world.
Are you going after class 3 medical device approval, or is it PMA approval? And then where are you at in your FDA regulatory pathway?
Yeah. Steve, you want to take that one?
Sure. So many contact lenses are classified as class 2. And so our initial pathway is class 2 de novo. There is a possibility it could be a class 3, and we'll know that when we do our pre-sub. And so we haven't done that yet. But as we mentioned in the video, we are engaged with the FDA through their Breakthrough Devices program. And so we're in constant sprints with them on different topics ahead of our formal clinical trials and submission.
When do you plan on submitting your package?
So we're a couple of years away, and we can talk in more detail on the impact tables.
The others?
Hey, this is Ben. Quick technical question, actually 2 of them. What's your field of view, and is it full field or not? And what's your current battery life, and what are you targeting?
Mm-hmm. Working backwards again, our view on battery life is that what we're striving for is an all-day use. Put it on in the morning and take it off at night. Now, that doesn't mean that the battery in the contact lens could provide you AR or VR content continuously for whatever, 8 or 12 hours. think more along the lines of duty cycling, like your mobile phone or your smartwatch, where the screen is not always on. So with duty cycling, our goal is to make it last all day long. What were the other questions there? I'm sorry, I've lost the other ones.
Field of view. Is it full field of view or is it partial?
It's what you would call partial, but it's actually another one of those areas, just like the user interface, that's really fascinating. When you are looking at the room you're in right now and your eyes are moving around in your room, you are not actually viewing that room with ultra high resolution. It feels like everything's high fidelity. It's not. You're scanning a very small portion of your field of view called your fovea with high resolution. You're scanning it around the room and you're building up in your brain a model of the surroundings. And that model, to you perceive that model to be a high resolution model of your surroundings. But it's really mostly made up by your brain filling in gaps and so on. With the contact lens display, the display sits right on your eye. And whenever you move your eye to the left or to the right or up or down, the display moves with you. And in the same way, a limited field of view on the display can actually feel much more expansive, because wherever you want to look, the content is always there. And you end up building up in your brain a bit of a model of that digital content. It's a kind of a difficult concept to explain with words here, but field of view is a topic that doesn't directly apply to an AR contact lens.
Mark, did you have a comment?
That's interesting.
I had a quick question. So Samsung a number of years ago built a contact lens with a camera in it. I don't think it ever seen any traction. Have you guys looked at that or considered that? And additionally, I know the Air Force was working on some technology that could change the IR absorption of the eye to detect where camouflage was over certain tanks and so forth. Have you guys considered that?
There is a whole world of awesome application that can be unlocked here by using image sensors with different wavelength sensitivity outside of the visual range where a human normally sees, and being able to pipe those views into the contact lens with false color overlay kinds of views. So yes, do we envision that over time we can integrate other kinds of cameras into the system broadly? They may be external cameras that you're viewing and not actually mounted on the contact lens, but then to give you those other wavelength views, yes, that's something that's very exciting and we're working on. But the short answer is we do have an image sensor in the contact lens. Right now, that image sensor is heavily targeted at our low vision user population. What we do is we take the imagery off of that image sensor and directly pipe it over to the display. So the data never leaves the lens. And in that process, what we can do is we can take those images from the image sensor, enhance them with contrast or edge detection. And then when you see the display, that display, the edges, let's say edges, the edges are perfectly overlaid on top of the real world, no matter where you look. So if you're looking at a person, you're going to see the outline of their face. And if you snap your eyes over to some other object, immediately the edge detection is working on the next object. So did that answer the question, Steve? Drew, anything to add to that?
No, it did. Thank you. It was Mark Jones from Sprout. I do appreciate it. And what are you guys going for another round of capital? I mean, what's the build capital requirements on the end game here? I'm just curious.
Yeah, Drew, you want to take that one?
Sure. This obviously is a very expensive program. We've already raised over $159 million, and it's going to take more than that. So we do continue to talk to investors and expect to raise additional capital and announce those fundraisings in the future.
All right. Thank you very much. And
one more. Based on that, what's your target price for the user?
Steve, you want to jump on that one?
Sure. So when we reach scale, our goal is to have 2 lenses plus our accessory be comparable to a high-end smartphone. And so that's the expectation, is that you'll wear these lenses for a year and you'll need to replace them on an annual basis. So it'd be some sort of subscription model.
All right. Thank you very much. And Max, I'm throwing it back to you.
Well, I'd like to say thank you to Mojo, first of all. Appreciate the conversation. And I'd also like to thank, more generally, all of the participants. That brings us to the conclusion of our video and pitch portion of the programming. So I would like to thank all of our participants. You all went through a very competitive process, and you put a lot of time into it, and in-depth mentoring, and you all did a really great job. And you're going to make life pretty hard on our judging panel, and we appreciate all the work you've put in. We will be convening the impact tables for those on the live stream. We will be going offline until 3 p.m. At 3 p.m., we will be convening a panel led by Tom Flake, focused on the emerging private sector space economy. And at the conclusion of that, we will announce the winners from today and yesterday's event. Thank you.